Hi, my name is Boris Masesa, and I'm here to explain about the assignment 3 for the driverless car pathfinder. I use Python. So I have two files here and a README, a Markdown file that should explain the whole theme of the project. And I'll start with my first file, which is the load network.py. So in this file, I just started by importing a collection. I just call from collection import the queue and then import also heap queue. And then I use the heuristic matrix to just give the distance from the Google Maps in a simplified way by initializing the routes. As you can see, VA stands for Vancouver, BU Barnaby, RI for Richmond, SU is for, sorry. Then I define my function, heuristic function. I pass the parameters for seat 1 and seat 2. It returns the distance between two cities, which is seat 1 and seat 2. And I want to get like a float number over there. And then I define my class called Unified Road Network. So within this class, I have a bunch of methods that where I try to implement the whole thing for the assignment. So I have the one that's called the add connection that passes like 3 parameters, which is seat 1, seat 2, and the distance, so that I can add a bi-directional road connection between the cities with a given distance. So I just use like if statement here. If seat 1 is not in the network, I'll just record it as an empty object, and then I'll pass it so that I can keep on adding it into my network so that it's easy for them to come and use it later. Then I have another method called neighbors, which passes only one parameter, calling it a city. This returns the neighboring cities and the distance for the given cities. So, and then now I'm coming to implement my A star search algorithm. So in my A star method, I'm passing two parameters, which is the start and the goal. And I want to perform a star search algorithm to find the shortest path between the start and the goal cities. So I will start by having like a set where I'll initialize everything as a 0 from the start and the goal as well. I use my heap. Then I'll give a variable visited as a set so that it can keep the records. And then I have my while loop here where I open the when I open the open set, so it just keep a track to see what's the current cost, the current city, and the path that I have taken. And then if the current city is equals to the goal, I'll return the path. And if the current city is not in the visited, so I will try to add it into my heap to keep a record for it. For the neighbor distance, in this, I'll try to keep on adding them up, and then I'll just try to loop it inside it and use the if condition to see if the neighbor not in the visited, and then I'll try to calculate to see the total cost, and I'll try to push it on my heap queue, and so that it can keep the record and be able to give the easiest route to get there. At the end of the day, I'll return it. Then I also you implemented the Dijkstra search algorithm, which is basically also looking for the shortest path, because I want to give the user an option to choose either an A star search algorithm, or to use Dijkstra search algorithm, or to use the Grassfire search algorithm. First, for this Dijkstra search algorithm, the method also takes two arguments, which is the start and the goal. I give it as a set, and then I use heap queue, and then I use the same way I did with my A star, but it's kind of different right now. Within my while loop, I'm keeping a track for the cost and the current and the path as well within my heap, and I'll keep on like popping and pushing it. And if the current position that you are, or the current city that you are, is equal to the goal, then I'll return the path for it, so that it keeps the record for it to look for the shortest path that I'll be able to move from one city to another city. And then I did the same for the Grassfire search algorithm. And then at the end of the day, I want to be able to display now the networks between the algorithm that I've tried to implement here for both A star, classifier, and Dijkstra. And then here, I'm trying to say when I want to display my networks, I want to print the road networks for visualization. So I have another file that's mainly for displaying to be able to see what is going to happen. And when a user is being prompted, where do you wanna, what's the starting city, what is your goal city, and what algorithm you wanna use, and then the system will be able to be um, to generate a shortest path that will be able to help the user to move from one city to another. So here you can see I'm trying to assume that unified network, so I will add the method as defined to the connection. Here you add your connection based on the actual distance. So I just had to put them manually by putting the network, which I already defined on my red networks, that I'm adding a connection from Vancouver to Burnaby. It will take a distance of 10. From Burnaby to Richmond, it take a distance of 15. And from Richmond to Surrey, it takes to 20. So you can keep on doing that. Then here I'm just printing the Unified Road Networks pathfinding, print a variable city. So you, instead of typing Vancouver, you're gonna use it in a short form, as you can see. And then now I'm gonna prompt a user to put what's the start city, what is the goal city, and what algorithm they use. And then now I'm trying to look for the logic here. If the algorithm choice, the OR is equal to A star, then it should have to return the A star search method that I already implemented on my own network. Else, if it's Dijkstra, it should return for the Dijkstra, should implement the method for the Dijkstra. If it's the classifier, I should do that. If it's different than that, should say invalid algorithm choices, and then it should return it. And if the path is already been found, based on the algorithm that we choose, we add a joint with an arrows to show the particular path that we taken. If there's no path, then it should return no path that has been found between the cities. So I'll go and try and test it here. As you can see, it's asking me into the start city. I'll say I want to move from Vancouver. And then what's the goal city? I'll say Barnaby. And then what algorithm I want to use? I'll say A star. And then it says the path that has been found is from Vancouver to Barnaby. I'll try to learn again. I will say the start city is Barnaby. I'll go to Surrey, USA. Now I want to use Dijkstra. So I'll type EJ Dijkstra algorithm here. And then it shows me the path that has been found. So we'll move from Barnaby, we go to Richmond, and then to Surrey. Let's say now we input a long information. I'll say Barnaby to Abbotsford, which is AB. And now I just type something which is different. I said, and say it's invalid algorithm choices. And then, yeah, thank you so much. And here I have my README where you can go through. It's just gonna explain like everything that I've been able to do. Thank you so much, and have a nice day.